Right. Well, good morning again. My name's John DeVries, and with a large crowd like this and only an hour, obviously we're not going to have a whole lot of time to get to know each other individually. I'm going to assume you're all C# programmers, or at least interested in it, or you wouldn't be here. Um, what I've done today is pick off some recent trends and topics that I think the people, well, in the classes that I teach, these are things that I make sure people are aware of what's going on with Microsoft C#.net, because as many of you are probably aware, things have been changing much more rapidly than they used to in the old days. Again, I'm a full-time technical instructor at New Horizons. I do focus mostly on programming, cloud services, Azure, Microsoft 365. I actually learned C programming back in the late 70s on Unix systems, but I spent most of my career in the industry as a product manager, a lot of data communications products. Then I had my own web development company for about 12 years after that. Now I do this full time. So I've seen a lot of these things come, I've seen them go. This is the way I kind of structure learning C# and object-oriented programming. That we have a number of courses, I'll show you that in a minute. And the basic structured programming, then object-oriented programming, then more advanced stuff. We might get to talk about a little bit of that today: composition, interfaces, dependency injection, and then specifically Azure and programming in C#. There's several courses in this area. I'm doing one of these, actually two of them over the next couple weeks. So, but let's take a look at what's going on. I thought I'd start out with some of the changes that have been happening. There was a time, wasn't that long ago, right? 10, 15 years ago, when things stayed pretty much the same for years at a time. Today, Microsoft is giving us a new version of .NET and a new version of C# to go along with it every single year. We're currently on .NET 7. 8's due out next, 2 months, right? November. And 7 doesn't really count for much. You may be aware Microsoft has gone to a system of alternating years with what they call a standard term release, which only lasts for about 18 months, and then a long-term support release, which lasts for 3 years minimum. .NET 6 was the most recent long-term support, and so that's the one most people are still using in production. .NET 8, when it comes out in November, will be the next long-term support. I kind of view, because they're only around for about a year and a half, I view the standard term support releases more as kind of previews of what's coming in the next long-term support one. But there have been a lot of big changes, and if you haven't been keeping up with it, or you're in an environment where they're still using an older version, it's easy to lose track. So I thought we'd start out by talking about what I think are some of the more significant things. Let me show you something, because I put up some code here in Visual Studio. What you're looking at is the program.cs file of a standard console application template. And if you haven't been looking at console apps for a while, you might be thinking, where did everything go? There's not much here. There's no main class. All that stuff is missing. There's no using directives at the top. And what you're seeing is partially one big change that was made, we'll talk about, but part of it's just the cumulative effect of a number of changes that have happened over the last 3 or 4 versions of .NET and C Sharp. And so let's take a look at how we got from the old version to this new one. Where are all the using directives? Well, they're still there, but they're in a different place. One of the things that Microsoft did, this was in C Sharp 10, that's the .NET 6 version that came out in November 2021, is allow you to have what are now called global using directives. And I figure we should always refer to the actual documentation online, since it's the only thing you can really trust. So, oh, by the way, I meant to, hold on a minute, let me minimize this. I want to make sure that you've got all the references for this. So now that most people are on board, let me give you in the chat, I'm going to give you a link. I'll post this for everyone. There we go. That is a link to a public shared folder in Google Drive that I have. And this presentation that I'm showing you right now is in there if you want to download a copy. So all of these links to the various Microsoft documentation pages, they're all going to be there. So that's something, you're welcome to that if you want it. Let's take a look here. So using directives, this is the big change, the global using directive modifier that was added in C Sharp 10 .NET 6. And if we look specifically at that, I think they've got a code example here. Yeah. If you mark on it, it's kind of like an access modifier, all of a sudden it applies to your entire project, and you don't have to keep repeating the same using directives over and over and over again throughout every file in your project. There is always a list of namespaces, class libraries that we all use all the time, right? System collections.gen. I call it the usual suspects, because there's that list you always see at the top of almost every file. And Microsoft finally said, well, it's kind of silly to make everybody repeat that every time, because we all know we use it almost every file. So they finally gave us a way to do this without having to repeat them in every file. Just mark it once as global, and a global using will then apply to every file in that project. So it's quite nice, and it's a significant change in the way things happen. And it's why in these newer templates, there's no using at the top of this file, because there's another place where the globals are defined. There's a default set of globals that are included with every project. And so this just picks it up from the global usings. What else? Top level statements. Much of what you are seeing here is top level statements. And they're a new feature that came in, I think, actually in .NET 5, but most of us didn't really pay attention until .NET 6 came out, and this became the default template. It's the normal way things are going to be done when you build projects from one of the newer templates. And I saw a very interesting discussion. Some of you may be aware of Tim Corey, who has a great .NET C# YouTube channel. And his attitude on this, because I'll be quite honest, when I first saw this, I wasn't sure I liked that, right? There's a lot of stuff not being shown. But he made a good point. Program.cs, we used to have inside of it a class named program. And inside of that, we would have a method named main. And that main method was the place where the thread of execution was always going to begin in your program. And yeah, this is a console app, but there were equivalent places in the other project frameworks, MVC, Razor Pages, etc. And he made a good point. The main method isn't really a method in the sense that methods are meant to be called from other places in your program. The main method was always marked static, right? Static methods are instantiated when the program starts executing. And the main method can't ever be called, because where would you call it from? You'd have to call it from outside the main method, but the main method is where the thread of execution actually starts. And so really, it's just kind of magic. It's the place where the program is going to begin executing. So why do we need a method? Well, it turns out you don't. What Microsoft has done is shifted the focus of the magic away from a method onto program.cs. They have just said, now you just have to start writing your code in program.cs. Now, you're only allowed to do this for one file, and it is where your thread of execution is going to be coming from. But it really simplifies the structure of programs. And if you think about it, it gets rid of a lot of extraneous stuff where the thread of execution begins. So yeah, it's quite nice. And once I got used to it, I kind of prefer it this way. So certainly makes it easier to teach. All right, so what else we got? Those of you who have made the transition to .NET Core. Now, if you're still on .NET Framework, the old Windows-only version of .NET, please get off of there. Microsoft, as far back as 2015, was recommending that you should not be starting new projects in .NET Framework. All of the new stuff we're talking about doesn't exist in .NET Framework because .NET Framework is now in maintenance-only mode. It's not being pushed forward any further. So all these new versions of C# with their new features, they're not supported in .NET Framework. But versions of .NET Core prior to .NET 6, there are some changes that happened in .NET 5 and 6. And one of the big ones, you may remember that, let me open up a program here. We'll just launch Visual Studio. And I'll just open up a standard little .NET Core MVC program. In the early versions of .NET Core, your start of your thread of execution was in program.cs. Here, we'll open up this guy. So you had a program.cs file where the thread of execution was going to start. But there was also startup.cs, and the method, let's take a look here. Here's program.cs. So here's the main method, which we don't need anymore because of Toppleder. And if you look at Create Web Host Builder down here, it invokes the startup class. Well, that's over in a separate file, startup.cs. And there are two major things over here, two methods. One, configure services, is where you set up all of your services for dependency injection. This is how Microsoft manages the built-in dependency injection container that's part of .NET Core. So this method here simply, if we look at it, lists out all of the services that you're going to set up so you can inject them later on in various parts of the program where you're going to be using them. And then just below that, there is a second method called configure, and that is your HTTP request pipeline. This is a set of operations that are performed in order. So when an HTTP request comes into this program, it goes through all of these operations, that one, followed by that one, followed by that one, in the order from top to bottom. All of this stuff has now been moved over into program.cs. I guess people were pointing out to them that, hey, we don't really need two files for this. And they finally agreed. So as of .NET 5, technically, but again, because 6 was the long-term support release, I don't think most people really noticed this until 6. Everything's in program.cs. One other big change. This one you may be aware of, depends on how much you're keeping up with what Microsoft is pushing as their most recent project framework. Blazor seems to be where it's at right at the moment. You may be aware, we went from .NET MVC, which is what this is. This is an MVC program. And from there, we went to Razor Pages, which a lot of people have mixed feelings about because of the reintroduction of code behind pages in Razor Pages. Well, now it's all about Blazor. If you go and look at .NET and go here to Web and look here at Web Apps, it's all Blazor. So Razor Pages isn't gone, it's still there. MVC isn't gone, it's still there if you want it. But Blazor, now if you're not familiar with Blazor, Blazor is more of a single page application project framework. It's a little bit like Angular, React. It uses Razor syntax. So everything you know about Razor that you may have learned in MVC or Razor Pages, that's still good. But it architects things a little bit differently. And actually there are server-side and client-side implementations of Blazor. The client side is done as a WebAssembly in C#. And you can even use them in hybrid mode. So you can do some stuff server-side, some stuff client side. So that's currently where the world is. Well, it's where Microsoft wants the world to trend. It's an interesting framework. The one takeaway that I can give you that is a relatively stable point here, man, they are committed to Razor. And my programming background before I got involved with .NET is more open source. So I tend to be an HTML, CSS, JavaScript kind of guy. But I got to admit, there's many things that I really like about Razor that I think make it a really interesting syntax for dealing with user interface views. So Microsoft is heavily committed to that, and they aren't going to be giving up on Razor anytime soon. So those are some of the, I think, the more interesting major changes. One of the things that is making teaching C# programming. Much more interesting these days is the fact that things are evolving very quickly. And therefore, if students are learning it one way, they only have to look back or ahead a few years to see something that can be substantially different from what they learned, which can be a little bit confusing. So just be aware things are changing. All right. One other big change, but this one I have mixed feelings about. Immutable types. Those of you who keep up with trends in programming, you've probably come across immutability as a concept that was, I think, really pushed heavily as part of functional programming, but has kind of been leaking over into other languages, particularly C#. And back in C#9, which would be .NET 5, Microsoft introduced a new type. Now, you're probably all familiar with, the standard types that we've had for a long time, structs, classes, interfaces, enumerations, delegates. And those are great. Well, we now have a new one, the record. And records create immutable types. Once they have been initialized, they can't be altered. And that has a lot of really interesting uses. Some of you may have come across the more recent practice that when we create a data item, we often today assign it to a constant rather than to a variable because we don't want it to change. And by assigning it to a constant, it can't be changed. It'll throw an exception if you try. And therefore, it's a great way of controlling a source of error. Well, the record type is the same idea for complex custom data types. And that's really, really nice. But turns out they didn't think this one through as fully as they might have. Because when I was reading through on this, turns out there's some problems, particularly with Entity Framework Core and some other data access class libraries, possibly, where some of their features do not work as advertised if you use records as a type. I don't think it's insurmountable, but I think they have a little bit more work to do here before this is completely baked. And so no of these, but I'd be a little bit cautious using them at the production level till they sort this all out. All right. Big trend in modern programming, polyglot data storage. Some of this is coming from the cloud because, well, those of you who have written applications that run in your own on-premises data centers, we try and stay within the boundaries of what the IT operations people currently support, right? And if I were to go to IT and say, hey, I know you're currently running, let's say, Microsoft SQL Server, but, I would really prefer to be using Oracle or some other database for this particular project. You think you could make that happen for me? They're probably just going to chuckle a little bit and say, no, you get to use Microsoft SQL Server because, the cost to operations to acquire, install, and support another database system is quite substantial. But in the cloud, that cost doesn't exist. All those things are already there as platforms, and we get to use the data storage we want. So we're looking today at much more varied types of data storage. Relational isn't going anywhere, but what are generally called NoSQL databases which is an ironic name given that the most popular way of accessing data in a NoSQL database is, you guessed it, structured query language. NoSQL, which is a loose family of several different partially structured data stores, actually has some big advantages, particularly for high performance applications. NoSQL started with simple key value stores, but very quickly evolved to what are known as document stores, where the key usually is an index of some kind, and associated with it is an entire document in XML or JSON or some similar format. And the document contains key value pairs all associated with each other. The nice thing about document databases, they do not have a fixed, rigid schema the way a relational database does. And so they're much more flexible. Also, retrieval is just simply know the key and go get the data associated with it. And so, for example, if you were doing, this is the people I always pick on for this. Let's say you were building something like WeatherBug. The key is your location, right? So I pick a location, and what happens? It goes out and it just retrieves a document. Now, I don't have any insight into the behind the scenes of WeatherBug. However, it's more than likely this is a single page application. It's how I'd build it. Seems reasonable, right? So it downloads this page once when I first connect to their server. And after that, as I change from one location to another, it's simply going out and retrieving the data and putting it into the appropriate places on this page. So I'm not getting any HTML, CSS, or JavaScript updated. I'm simply getting probably a JSON with all of the weather data for that location. This is such an obvious application for a document database. It's hard to imagine they do it any other way. And the performance is going to be much, much better than with trying to do the equivalent thing in a relational. And then, of course, we can have graph API databases today if you're dealing with data that fits that kind of a network-based structure. Y column, I haven't seen too many uses for, but they're out there. Y column, if you're not familiar, they're designed to be retrieved by going down the column instead of across the rows. And then an unstructured file. But the point here isn't the specifics of any one of these, it's the fact that you've got them all for the asking. And it's just a matter of setting up the service. I'm not saying there's zero cost. There's always a certain amount of operational cost, getting familiar with the technology, etc. Nevertheless, if a NoSQL database is what fits your needs better than a relational, you're no longer constrained to working with a relational because that's what IT has installed. So Microsoft's in Azure, their big NoSQL platform is Cosmos DB, which, by the way, is all four of these. It can be configured for any of those APIs. And the idea would be crafting applications that would use a combination of relational. They've got an Azure SQL database, NoSQL, blob storage for unstructured file storage. They're using some Synapse Analytics stuff for big data storage because this is an Internet of Things application. And this idea of polyglot storage, as more and more of our apps tend to be moving into the cloud, this becomes possible and a very attractive option. So definitely something that we're seeing A lot more of on the design side, and we're seeing Microsoft really pushing this from the education side. Here's another one, a healthcare app where there's an Azure SQL relational database, data factory, blob storage, excuse me, Cosmos. Phew, excuse me. Healthcare made me sneeze. All right. If you have not worked with Cosmos yet, highly recommend getting to know it. A lot of my first introduction to these technologies, open source, MongoDB, which is a document database, but Cosmos actually accepts the MongoDB API. So if you wrote an application using Mongo, you can actually just switch it over to Cosmos with essentially no change. And they thank you, Sri. All right. And that takes us to another trend that we're seeing. Distributed cloud apps, highly distributed apps. The trend here has been going on for a long time, but it basically went one step and just stayed there for a very long time, because as long as apps were running in our own on-premises data centers, there was really not much incentive to outsource functionality. The one we did was databases, right? It's been a long time, 25 years or more, since anybody crafted their own data storage for an app. You know, when I learned programming back in the late 70s, if you were storing persistent data, you wrote a custom file format because there were no databases. Well, let's put it this way. There were no readily available ones because the computers of the time weren't fast enough to be running both your app and a database. Today, that would be an absurdity. So we came very quickly to rely on databases for persistent data storage once they were readily available and the costs were reasonable. Yeah, we're kind of going way beyond that these days. Here's a fairly simple, by the way, all these diagrams, they're straight off of Microsoft's architecture web pages. So nothing that I came up with. Simple web app. So we've got an Azure web app service, Microsoft. You may have noticed, those of you who work with Azure, that what was once upon a time an Azure website in the old classic Azure became an Azure web app when Azure Resource Manager launched in 2015, was gradually being transitioned to be an app service as they combined the API app and the mobile app templates into the one called just app service. But all of a sudden, about 6 months ago, reverse direction and is going back to being called a web app. So web app service, whatever. It's a way of running a monolithic chunk of code. So that's at the heart here of this application. But we've got a connection to a caching service. Redis is the one that Microsoft supports. Azure SQL database for relational, content delivery network, monitoring. We'll talk about application insights. Yeah, let's look at something a little bit bigger and a little bit more realistic. Still got a web app at the center of it. So this is running your monolithic application code. But look at how many functions are being outsourced to cloud services instead of being done in your own code. Queuing. There's a functions. Azure Functions are a way of running. It's a serverless runtime environment for running small chunks of code. And this is actually being used to isolate the code that interacts with a third-party credit card payment API out here. So that if they want to either switch services or if this API changes over time, all the changes are isolated here in the functions. They don't have to worry about changing the code in their core program. The queue storage is in there for buffering, because if you outrun the capabilities of the API in terms of transactions per second or whatever, you don't want to be dropping credit card transactions on the floor. So they put a buffer in with a queue storage. But then look at all the other stuff we've got. Multi-factor authentication being done through Azure Active Directory, Redis again, blob storage for files, Azure SQL database, Azure search. They don't do their own search within the program. They've used the Azure Cloud Search Service. This is becoming a commonplace. I often, when I get to the topic of microservices in my classes, quite honestly, my personal opinion is that microservices have been a bit overhyped. Not that I don't Kubernetes in particular, but the fact is that everybody talks about microservices, and the bulk of the applications don't need a microservices platform. And part of the reason is because you can do this instead. Here, it's kind of the same design strategy as microservices, except we're outsourcing the functionality not to other services that we created, but to cloud platforms that the cloud vendor is providing. Here's an even more complex one with a secure app where we've got multiple web apps dealing with different aspects of the website, multiple databases, caching again. Now, there is a major issue when you're dealing with this architecture. And there's a constant in all of these diagrams. It's this guy, application insights. It's here in every one of these. Because one of the problems that you get into with highly distributed applications, how do you keep track of what they're doing? We've got two issues. One is just an awful lot of pieces to keep track of, right? Yeah, that's bad enough, but it's actually worse, because sometimes the problem isn't in one piece or another, it's between them. They aren't communicating correctly. How do you see that? Well, Application Insights was specifically built to deal with that issue. It gives you a monitoring platform that runs in Azure that can be hooked up through either a code agent that you install or through built-in agents for Azure services that report data back. And anything running anywhere that has line of sight across the internet back to Azure can be hooked into Application Insights. So all of these services are rights. Your server-side code can report data back to it. Your browser code running on the client side, those can also be reporting data back. And in fact, Application Insights, some of you may have worked with Google Analytics for tracking usage in websites. Application Insights has a very, very similar capability, plus a lot of operational monitoring and analytics that you don't get with Google Analytics. Also, there's a really nice thing that they did about a year, 2 years ago. There are two aspects that we need to keep track of an operational environment like this. One is, of course, real-time monitoring. The IT operations people need to know what's going on, so when it breaks, they can fix it. Yeah, but if it's broken, often the way we need to look at it to see what's wrong is through the log files. And trying to coordinate log files that are spread across so many different pieces working together, that is no fun. I've done a lot of log analysis over the years, simply trying to coordinate the timestamps so that you can see what the correct time order was for the events is a non-trivial task, except that Application Insights does it automatically now. There is an associated, what Microsoft calls log analytics workspace, and a query language associated with that allows you all of the data, all of these things that are reporting back to Application Insights for real-time operations data are also reporting all of their log data back here, and it's been put into an associated log analytics workspace that's been set up automatically. And one of the nicer things that they did recently, this used to be you had to go and get an SDK, software developers kit, and install the proper class libraries into your applications. They have now added auto instrumentation so that as long as you are running this in a Azure environment, it's automatically reporting stuff back to Application Insights. So they've got a little table here in the doc page showing the different versions of .NET Framework, Core, and also some other languages, and where this auto instrumentation capability is supported for the different runtime platforms within Azure. And you can see for .NET Core, you get support for a lot of them. Oddly enough, for Java, you get everything. So that's interesting that they support more on the Java side. But that's really nice because it doesn't take any effort to wire this up now. It just happens, as long as the code is running in Azure, of course. If it's in a different runtime environment, then you have to still use the SDK to wire it all up yourself. So the combination of distributed architectures running in the cloud and monitoring tools like Application Insights that allow you to monitor real-time operations and collect coordinated log data, really, really powerful combination. Just keeping an eye. How are we doing here? Oh, we got a few more minutes. Which, of course, brings us to what else is out there in the cloud. You've all been hearing tons and tons and tons and tons about AI for the past year. Ever since ChatGPT blew up, it's all anybody wants to talk about. They don't understand what they're talking about, but they talk about it anyways, right? You know, and you'll see regularly these, you know, as well, those of you monitor like Stack Overflow or some of the other typical forums, you know, is ChatGPT or any other kind of AI going to take our jobs away? I've been at this a lot longer than most of you. In fact, in my memory, it's probably about the fourth. I can remember going back to the 1970s. There were technologies that people were advertising it was going to remove the need to have any programmers. Funny, it didn't happen. It's not going to happen this time. What will happen that I think is going to be really, really nice for us as programmers, the tools are going to get a lot smarter. You've already started to see this happening with Visual Studio Code, where the AI-based IntelliSense is making much smarter suggestions than it used to. Sometimes a little bit spooky on how smart it is, but what you're likely to want to do next. And that will only get better. I think what's going to happen is the boring, repetitive, tedious parts of programming will tend to get automated. But the creative side of designing a really good application, nothing is going to change that. We still need programmers. On a more narrow front, one of the big things we are seeing is AI as a user interface is radically altering how our programs interact with users. Some of you may be familiar with a gentleman. His name, do I still have it open here? No, I think I closed it. His name is Jacob Nielsen, and he is one of the gurus of user interface, user experience. You may have some of his books. And I get his monthly newsletter from his consulting company. And a couple months ago, he was talking about the fact that AI is really the first major new user interface he's seen since the graphical user interface was introduced back in the 80s. And that's some significant change. It's not just a change in how we program, it's a change in how our programs are going to be expected to interact with the users. If you do not keep up with this stuff and start incorporating it into your programs are going to kind of fall behind the curve of user expectations. People will expect them to have capabilities, to be smart enough to do things. And if they're not, they're going to find somebody else's program to interact with. So I've got a couple pages here. Let's see, I think I have these open. This guy. The press likes to talk about artificial intelligence because it sounds cooler, right? I call this machine learning. I have yet to see any of this stuff that isn't basically machine learning, and I teach that. Machine learning is nothing but statistics. It's pretty advanced statistics at a level, of volume in terms of the amount of data we're processing that we couldn't have conceived of a couple decades ago, but it's still statistics. It's nothing magic here. But in terms of the capabilities of how a user can interact, cognitive search. If you are not using a machine learning powered search service as part of your program, people will start to notice that your search is dumb. In other words, it can't figure out what they mean, whereas other people's searches seem to be much smarter about that. Because cognitive AI-based search can do things like recognize synonyms. I'll give you an example that some of you may have been through. Buying a house. If you were searching for a house with a water view. Think about this. How many different ways can you come up with that a real estate agent might list a house with a water view in a listing? Waterfront, oceanside, beachfront. I mean, you can come up with dozens of different ways of saying something that would indicate the house has a water view. And, only an AI, machine learning based tool, is going to be able to figure that stuff out. So that vision recognition, content moderation, if you are building a website, that one's retired. Content safety is the new one. If you're building a website that allows comments, you can't. I mean, for legal and compliance reasons these days, you can't allow that to go unmoderated, because somebody will put something offensive to somebody else in your comments. You've got to moderate it. But on the other hand, people are expensive. You can't really afford to do it that way either. AI-based, machine learning-based moderation is the answer. Vision, being able to turn documents into data, being able to run apps off people's smartphones. I mean, there's a ton of stuff here. And if you're not starting to make use of it, your apps will start to fall behind the curve of user expectations. So here's typical Azure Cognitive Services app. They've used, again, this is that serverless functions environment with text translation, computer vision, face recognition. All right, one more. That's all we got time for. Cloud design patterns. You're probably familiar with the concept of design patterns. Gang of Four, going back to like 1998, right? It's been 25 years. So design patterns are not exactly anything new. But the problem is I still see a lot of programmers not really taking advantage and making use of them in their day-to-day programming. So I just wanted to talk, we're getting kind of a little to the Azure Architecture Center, where you can find all of these cloud design patterns right here. Just a couple real quick. Some design patterns are what I call blindingly obvious, like the retry design pattern, which basically boils down to, if at first you don't succeed, try again. Because particularly in internet-based applications, transient errors are very common, right? It works and it doesn't work, and then it works again. So retry is just a smart strategy. Okay, big deal. Yeah, well, there's another part to this. There is a matching design pattern called the circuit breaker, which takes retry and automates, at some point you got to stop retrying, right? But it automates stopping the retry, but also self-heals, so it goes back to normal operation once the service is available again. So there's a bunch of these that you should be familiar with. Some of the ones that are in the Microsoft, the Azure Architecture Center, the cloud design patterns are similar to the Gang of Four, like the ambassador pattern. Some of them are not. But definitely something you want to get on top of. If you're not using design patterns in your program design yet, you definitely should be. And with that, I think we're out of time. Um, so, oh yeah, I did want to point out, we actually saw an ambassador pattern in one of the apps I showed you earlier. This is that e-commerce distributed web app, and the use of functions so that all of the code is isolated, the code that has to deal with the third-party API. That's the ambassador pattern at work. So, all right, well, I think we're going to wrap it up here because we're just about out of time. Brandon, I know you wanted to get a word or two in, and then after that, we can take any questions.
Absolutely. Well, thank you so much, John. And if we can all give John a round of applause or thank you in the chat, we so appreciate him and taking this hour to be able to give us his thoughts on C# and how it's impacting AI and all of that. So it's been an incredible hour. So thank you so much. As always, we'd love for you to follow us on LinkedIn, connect with us there, so that way you are up to date on everything going on with New Horizons. At the end of this webinar, once you leave, you're going to get a 1-question survey. And that survey is just simply asking, would you like to continue the conversation? All that means is if you are interested in learning more about what we've been discussing today or other topics that New Horizons offers, and you're like, you know what, I just need some help in knowing what New Horizons does and how we can actually support you and your business, go ahead and say yes on that question. We'll get you connected with the right people to have those discussions, and you can go from there. But yeah, just wanted to be able to get that quick word in. We have just a few minutes, so we'll hand it back over to John if you do have any questions. But other than that, thank you all so much for coming, and have a wonderful rest of your day.
All right. If you did have anything, go ahead and just type at me in the chat window. So I know. I always tell my students, one of my goals as an instructor is at the end of the session, I will have burned out enough of your brain cells that you can no longer formulate a coherent question. So, so if you can't anymore, I totally understand. All right. I think we've killed off enough of everybody's brain cells for one morning. Everybody have a great day wherever you are, and maybe we'll see you in one of the C# programming classes. So have a great one.